Hello friends, welcome back to BitSize Machine Learning. Today we're going to continue on our end-to-end ML in 15 steps. In our last video, we talked about how to do geospatial visualization using the longitude and latitude values in our dataset. Today we're going to continue our discussion by doing some correlation analysis. So let's get started. So first of all, let's import some of the modules that we need for our analysis. From Matplotlib, we'll import path, we'll import NumPy as NP, Pandas as PD, Matplotlib.pyplot as PLT, and Seaborn as SNS. So if you haven't, this is the newest one, Seaborn package. If you haven't already, you can install it using pip install Seaborn. So let's just run this. So it's successfully loaded into our environment. So now let's take a look at the structure of our project again. So let's run the tree function again. So our data is sitting underneath the data folder, which houses the housing.csv. And then currently we are in the notebooks folder. Our Jupyter notebook is called 7, the correlation pairs.ipynb. So this is where we're at right now. And this is the entire structure of our data. And as usual, let's first load our data into a variable. So we're going to load the housing.csv into a variable called df. So let's just run this. So as usual, before, we also are going to run this create income bins. So we talked about this in the previous videos. If you haven't already, I strongly encourage that you actually go back and then watch how to do this. So let's just run this. And then using the this data set, we will feed the df, and we're going to create the binned df. So after that, we're going to feed that bin df to our stratified shuffling split function to create our train set and test set with a 20% test set and an 80% train set. So this stratifies based on the income bins that we created using this function. So let's just create the train sets and test sets. And train size, test size, so everything ran correctly. So now we're going to copy only the train data set for our analysis for today. So we're going to use train strat that we created in this step, and we're going to copy it and then put that into a variable called housing. So let's just run this. And then we'll also run the info method to take a look at the entire structure of our data set as well. So when we run this, it's going to give us the entire structure like this, and we have 10 variables, and then 9 of them are all numeric. As you can see, they're all floats, and then 1 of them is object, which is not numeric. So in this video, we're going to take a look at how these variables are correlated with each other. Specifically, we are more interested in looking at how the median house value is correlated with the other variables in this data set. So let's take a look at how to do this. Before doing this, let's just do create a variable called core, which stands for correlation. And in order to do the correlation analysis, let's just do housing.core. And then when you do this, and let's just print it out, and then let's just quickly run this. When you do this, it's going to give you a value error. It says, if you go back, could not convert string to float. So as we've seen before, there's one column that is object, that's not numeric. All the others are numeric. So we have to make sure that this correlation function is only looking at the numeric values. So in order to do that, we can just say numeric only and then true. And once you do that and then run this, it's going to only look at the numeric columns and calculate the correlations among the numeric columns. So as you can see, each column is one variable, and in each row is one value. It's going to look at the correlation between those two. And then the value that we are more interested in is the median house value. To take a closer look at how this value is organized, let's just extract that information. To do that, we're going to do core, and we're going to do median house correlation value, and dot sort values, and then we're going to send ascending is equal to false, because by default it's going to do descending order. So when you do this, it's just going to grab the median house values and its correlation with all the other variables here. With its own correlation, it's 1. if with median income, it's about 68%, 0.68. And then with latitude, it is negative 0.14, which is negative 14%. So those are very useful information. However, there are some correlations that are not very strong. For example, the longitude is only 4%, population is around 2%, etc. So let's just quickly grab the ones that we are interested in looking at into a Python list. To do this, let's just quickly grab the column name so that it's easier to just type in. To do that, we're going to do housing.columns. So when you run this, it's just going to give you the list of variables, the entire variable. And then let's just quickly create one list that we're interested in based on these values here. So we're interested in the median house value. Let's just copy that, median house value. That's the first one. And the next one is median income. Median income is the next one. And then the next one is total rooms. Total rooms is right here. Let's just quickly copy and then paste it right here. And we also have housing median age. So the housing median age is right here. You can also type this, it doesn't matter. Housing median age, and so that is around 10%. And then below this, it's going to be 6%. We're not really interested in that. 4%, 2%, 4%. And the last one is latitudes, which is negatively correlated, which could also be very informative. So let's grab that as well. Let's grab latitude value at the end. So these are the ones that we're interested in. So after creating this list that we're interested in looking at, let's quickly visualize using a heat map. So to do that, we will use the SNS package. Using SNS package, we'll use the heatmap function. And then with the heat map, we're going to give the dataset that we are interested in visualizing. So that is the correlation and dataset that we are interested in putting in. And then the attributes that we've just created as a list above this line. And then we're going to use the annotation parameter, which is going to just display the numbers inside the cells of the heat map so that we can see. And then the next one is the CMap. So the CMap is going to map out with the colors. We're going to use a cool, warm heat map mapping, and then in the at the end we're going to use the center argument, which is going to be the center of the cell. So after this, we're just going to do the PLT. We're going to give it a subtitle. Subtitle is going to be just a heat map. Okay, so PLT, let's do a tight layout. And then after that, let's show this PLT show. Let's just run this. And as you can see, it created a heat map. Just with the ones that we are interested in on the x-axis. We've interested in median value, house value. We are interested in median income, total rooms, and housing, median age, and latitude. As you can see, there are a couple of interesting values. The first one is the correlation between median income and then the median house value, which is about 70%, which is the highest among the correlations that you've seen here. And then the other one is the negative correlation among latitude and longitude. So this might be interesting. There are other high correlations, for example, total rooms with the households. So that makes sense. More households, more rooms, or more population, more total rooms, for example. So this gives us a lot of information already. However, if you are interested in looking at the distribution of each one and looking at the histograms, for example, or scatter plots, or how these ones are correlated using pair plots, that's another good way to visualize this as well. So let's do that. So in order to visualize it that way, we can do using the SNS, the Seaborn package. We're going to do a pair plot, and then for pair plot, we're going to give the attributes that we are interested in visualizing, and then we're going to do the corner is equal to true. So this is going to, because The pair plots, it's going to be symmetrical with the diagonal, so we're only displaying the ones that are the lower part of the diagonal. So we're not interested in the duplication of information. So we will say corner is equal to true. And then after that, we're going to do the diagonal kind, which is going to be, you can do histogram or KDE. I'm interested in doing KDE, so because it's going to give you a smoother kernel density plot. KDE. And then after that, we're going to do the plot keywords. So plot keywords, it's going to just give you the stylizing of some of the attributes. For example, in this one, I'm going to put the alpha value of our plot to 0.3 so that it's going to be more transparent so that I can see it clearly. So those are the main ones that I'm going to do. And then let's just quickly run this and then see what's going to happen. As you can see, this is giving us some number to get rid of that. Let's just copy the PLT arguments down below so that it will go away. And this is not a heat map. Let's give it a title. This is going to be a pair plot. And then let's just quickly run this. After that, it's going to give us the pair plot. As you can see, the diagonal is the KDE plot that we are interested in looking at. It just gives you the distribution of each variable that we've selected before. And then it will also give us the scatter plots down below. Scatter plots give us the relationships among each pair of variables. For example, we've seen earlier in the heat map that there's a strong correlation between median income and the median house value. And if you look at the scatter plot, median income, and then the first one is median house value, this one, there's a strong increasing, almost like a linear relationship. So once when the median income increases, the median house value also increases as well. So there's the strongest trend right here. However, the others are not as strong, or there are some bimodal distributions that are happening. For example, in latitude, we can see that there are two spikes, so which could be interesting, that it's suggesting that there might be two different latitudes. There are more houses kind of located in those areas. And then this others are all like unimodal, and they're kind of slightly skewed, and in some cases it's highly skewed as well. So it gives us a lot of information about our data. But in our data, as we've talked about before, we have a lot of numerical values, and then we also have one categorical variable called ocean proximity. We can actually take a look at how the ocean proximity affects our data as well by just directly mapping that into our pair plots. In order to do that, let's just add in the ocean proximity into this pair plot. And then we're going to, hue is also going to be ocean proximity as well. Let's just copy this and then give it the comma. And then after this, let's just run this. As you can see, now that we can see it clearly how the ocean proximity categorical variable is affecting the different distributions. For example, in the median house values, we have this green line, which corresponds to inland areas. And then we also have this orange one, which is an less than 1 hour ocean. And then it gives us different distributions, and it's making the visualization more clear, and it gives us more insights as to what our data is telling us about how the median house value is correlated with the other types of data in our data set. So this is the end of our today's visualization, and this is how we do pairwise correlations or other types of correlation analysis using either the heat maps that we've seen earlier with the correlation values that are displayed on top of them directly, or using the pair plots to look at how each pairs of variables are correlated together with all of the histograms or the kernel density plots, which gives us the distribution of our data sets as well, so which is very useful. So that's the end of today's BitSize machine learning tutorial. And in our next one, we're going to talk more about how to do some feature engineering, so stay tuned.